Even though you're like, I've only got a couple of like prepped examples in the queue, but I could certainly just conjure up some more. These aren't that hard to create, but they will all require the use of fractions. And because we want exact answers, we want to stay away from the decimals. So as tempting as it might be, there will come a point where honestly, for practical purposes, if I say like, what's half of 11, if you say like 5.5, but today it's going to be a big foul. So today we have to embrace the idea that when I say what's half of 7, you just instinctively say 7/2. Okay. Fractions never fail us. We sometimes don't like them, but fractions never fail us in that they are perfect. 2/3 is perfect. 0.67 is trash. There are practical applications and times when decimals do the job, but as a rule, we should master the art of exact answers, and then we can casually throw in ghetto decimal answers on occasion when that's appropriate. So today we will be using fractions, FYI. And honestly, a lot of today's work could be done with decimals. I'm just, as I tried to say just now, I'm not going there. I want everything to be perfect, and then we can branch out and do it other ways. If you got good basic skills, you're not gonna feel much pain here. So I'm gonna do this smaller one first, I decided. So here's our first example. And there will be more than two. I just only have two, but in thinking about this, we're going to probably want to do 3 or 4. So there's one big change today, but there's going to be some more like smaller cosmetic kind of changes. And that's going to be, there's going to be some terms sprinkled maybe in different places. So just be comfortable with kind of your target. Your objective is to make it look like it has been the last couple of days. And that is, I want my quadratic and linear term, my x squared and my x over on the left, and then my constant term on the right. So you just make that happen no matter what. Like you've got the skill set for that. Mm-hmm. So I'm going to move the 10, right? So what I'm doing right now is not anything to do with completing the square, but more just kind of prepping the landscape for what I know I need to do. So if I add that 10 across, I get 12. And we're ready to roll. So by the purpose of asking nicely, politely for you to get that assignment 34 done was that now I don't have to sit and answer questions about why did you do this or this. Like the algorithm, the process should now be ingrained in your, like your, it's in your skill set, right? So we know that the algorithm demands of us that the next thing we do is we take half of the middle term. So this is where it happens. So, and every problem on the new assignment will have odds. So there's not going to be like back and forth. We're going to go just practice completely for a couple days, odd middle numbers. So at this point, you take half of 3. And what is half of 3? It is 3/2. So I'm just going to ask that, and you just don't really, I mean, you're enrolled in this class, so you don't really have a choice. I need you to answer it as a fraction. So, and I'm going to write it down. So half of 3 is 3/2. And that number, as I've tried to get across to you, is going to help us later on in about a minute or so. I don't know. So the next thing I do, from this process repeatedly, is I do what with this half of the middle? I square it, right? Okay. And when you square a fraction, you have to square the top and you have to also square the bottom. Okay. So an exponent is distributable to the top and the bottom, whereas if we multiplied by 2, we would only multiply to the top. But an exponent requires that we square the whole fraction. So we're going to square the 3 and square the 2, and what are we going to get? Good. So we're going to add 9/4 right here, and we're going to add 9/4 right here. Everyone okay? We're good? Okay, it's time to factor. And never, ever, 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 ever in all the years I've spent with you have I asked you to factor anything that has fractions in it, but I'm about to. But as I was trying to convey to you, I could teach you this if you knew nothing about factoring at all. because remember, the layout of this, we know, having done like what 20 or 30 of these by now, is that it's going to look like this, right? And we know that there's going to be an X right here. And then all we have to do, and this is where it really becomes important, is we take that number, remember the half of the middle thing, and we just bring it in. Clear? So, I mean, you don't even really have to say, you see what I mean? You don't even have to really know how to factor. You just have to be able to remember that when you said what's half of that middle, that answer to that question before you square it is what goes into the factored binomial thing. So we're going to have x plus 3/2, right? And I mean, it's neat. It's like factoring, but you're kind of skirting around the idea that you're factoring. And unfortunately, this is one of the two parts. Like we haven't done anything yet that's even close to hard. This should not be, and I hope it isn't. Maybe you guys are the first year in a long time to break the mold, but this step causes stress. How do you add a whole number 12 and a fraction 9/4? Bryce? Bryce? Yes. Well, yes. And so the idea is I need 12 to play the look-alike game. And I say to 12, I'm like, you're not being a very team player here. So if I'm going to add you to like 9/4 can't become a whole number. So like someone's got to say, I'm going to look like you so that we can add together. And since 9/4 can't become a whole number, 12 says, I got you, buddy. I can become a fraction. So the key here is, and I'm going to walk you through this, and then of course the shorter thing is what Bryce said, but just kind of, I want you to see the behind the scenes. If I want 12 to be a fraction, I can rename him as 12/1, right? Fair's fair, but that does me no good because as your fourth grade teacher taught you, you can't add two fractions together if they don't have the same bottom. So this is where Bryce's input bails us out. And we say, well, I want your bottom to be 4. So what I can do is I can take the top times 4 and the bottom times 4, and that satisfies my mission. That takes this number 12 and it turns it into 48/4, and then I can add 9/4. And I wish it weren't the case in an 11th grade math class, but I spend a lot of time talking about that step right there. Turning a whole number into a fraction is as easy as what Swaggy B said, and that is just whatever you want the bottom of a whole number to be, and this goes blanket statement forever and beyond. Whatever you want the bottom of a fraction to be, just multiply the whole number by that number and poof, you've got a fraction with that bottom. It's like magic. So 12 kind of morphs himself into 48/4. He says, I still equal 12, but now I'm a team player because you can add me to the guy sitting next to me. So in this next step, what we're going to do, and you often, by the way, won't show this step. We'll show it in the first couple, but you get to a point where you just kind of start skipping it. But for now, I'm going to show, I'm going to keep this in its squared form, x plus 3/2 squared equals what? Good. And I don't know why I couldn't just write a 5. Let me try again. There we go. 57/4. So this should look familiar to you. This is the point in the process where we now do what? We square root. We're ready for that because that x plus 3/2 squared is like, I can't work with you until you get this dumb exponent off of me. And the only way to get that dumb exponent and free him from prison is to square root it away. So I'm going to square root the left side, leaving me with x plus 3/2. And remember, the moment you do the square root, what else do you do? Positive, negative. That sign introduces himself at that exact moment. Every time, right then is when he shows up. Okay. Now, I'm going to go off to the side here, and I'm going to use a color I haven't used yet, so focus over here. What I have is the square root of 57/4. This is, again, it's one of those things we don't do a lot of, but it's really not hard. In the same way that an exponent is distributable, a square root is distributable. So what this really is the square root of 57 over the square root of 4. What do you think about that? What's the square root of 57? Let me try that again. What's the square root of 57? There is one. Ulysses S. Calculator was reading it off to us over there. But really, what is the square root of 57? It is the square root of 57. Let's be clear. We would instinctively think about trying to square root it, and then we'd realize, well, 57 doesn't play well. And then we might think about making one of our cute little trees. But does anyone know the only factors of 57 other than 1 and 57? Yeah, 19 times 3 also makes 57. And so there was a chance that we could have broken it down, but 19 and 3 are like, I'm out. Like if all I have to offer is a 19 and a 3, well, you better just write me as the square root of 57. So we're stuck with that. But what is the square root of 4? Good. So we're now going to rewrite the right side as root 57 over 2. Good so far? Huh? We're almost there. The next thing that we have to do is move the 3 halves. And you see the process isn't changing. It's just that the work required to do the process is a little bit harder. So now I'm going to pick up the 3 halves and I'm going to airdrop him right, as you know, there. Okay. And so my new answer is x equals negative 3 halves plus or minus root 57 over 2. Now make your 4th grade teacher proud. Incoming question, don't fail me. Can you add those fractions together? Yes, you can, because their bottoms are the same. So the expectation at this point is that it's not really a pathway problem, like in that I can't really get answers like 12 and negative 4. But what I can do is acknowledge that I've got 2 fractions with a bottom that's the same. So the expectation here is that we would put them together, and it would look like this. Negative 3 plus or minus the square root of 57, all over 2. That's what your answers are going to look like today and Monday. Scale of 1 to 10. 1, I have no idea what in the heck you just did. 10 is like, that's easy. Where are we at? Is that a 10? 9? Easy? Great. Where we're going to get hung up, and it's usually 20%, 20, 30% is in the basic skills department. Like if you get hung up here, it's probably not because you don't know how to complete the square. It's probably because of the fractions. I'm sorry about that. So let's do another one, and then I'll whip up some more for us. This one's going to be a little bit more bigger numbers. You see right away that something strange is afoot, right? Everyone's kind of like messing with you here. This problem is trolling you and saying, it's picking on you, trying to raise your blood pressure. So what are we going to do to make it look the way we want it to look? Yeah, let's add the 44 because we know he's not where he belongs. And let's also say 15x, get back on your side, like stay in your lane, bro. So let's get the 15x back to the left. And let's get the 44 over to the right. And let's clear it and make it look the way we want it to look. So we're going to have x squared minus 15x. Blank space equals what? Good job. And at that point, you might feel like, hey, 36 is a square. Honestly, at this point, we really don't care because 36 is not long for this world, right? We're going to muck it up because we're going to add something over there, right? So let's get to it. Let's complete the square. What's half of negative 15? Negative 15 over 2. Saying or not saying that negative is something, it's a fight that I kind of probably just have to eventually give up. But negatives are really the bane of my existence. I spend so much time in red ink every year on people's refusal to acknowledge negatives. So when I say what's half of negative 15, you should say negative 15 halves, right? And that's important because when we do our factoring step, we don't want to botch the sign. So I'm going to take this negative 15 over 2, and I'm now going to do what I do, and I'm going to square it. What am I going to get? It's definitely not negative. Square, not times 2. 225 over, correct. So we're going to add 225 fourths to both sides. So far, so good. All right, so that's the groundwork, and now it's time to factor. And if I listen, going back, can you just imagine? I'm going to erase here. I'm going to vandalize some stuff, and then I'll just hit the undo button. Can you imagine when we remember how we started our year with like 6 weeks of factoring? Can you imagine how much anger there would have been if I put that on a test and said factor? I mean, that's like we just generally don't go down that road. But as I've said like 19 times now, you don't even have to know how to factor to do this next step, right? I know exactly how to build it. I'm just going to put parentheses with a square outside. I am factoring without even knowing that I'm factoring. And I'm going to put an X. Now, what number is going to go after the X? Minus 15 tooths. Very good. It's like, wow, I just factored a quadratic trinomial with a fraction in it. Sweet. And then the right side is the basic skills test. So let's again use Bryce's tutelage, wisdom on this. What am I going to do to that number 36? I am going to multiply it by 4. And that's going to turn it into 144 over 4. So watch as I work the magic eraser here. I'm going to take the number 36 and say bye-bye. And in its stead, I'm going to put 144 over 4. Did I change anything? No, it still equals 36. Everything's on the up and up. And now I have the ability to add those two fractions together. What's 144 plus 225? 369. So I now have 369 over 4, and you are not to insert the positive negative sign. Remember, that does not happen until the moment you take the root. Everybody got that? So please do not. I've seen people just throw the positive negative sign, and they're like, oh, you just said I was supposed to put it. It comes the moment you root. Okay? So in the next step, we will now square root both sides. And that's going to leave us on the left-hand side with x minus 15 over 2 equals positive negative. And generally, this is pretty predictable. Let me ask you a question. You should be able to answer this. Big brain question. Will that always be a 4?
No.
Yes, it will. And the reason for that is because that 4 is the result of squaring a 2. And let me ask you then a sort of a follow-up question. Will that always be a 2? Yes. Because when we're working with odd numbers, when I say to take half of something, you always divide by 2. And 2 squared, last I checked, is always 4. So you can rest assured that you're not going to be working with weird bottoms. Like the bottom, take it to the bank. It's going to be a 4. And so we can say, like, reliably that we're always going to be able to take the square root of the bottom. And quickly you figure out that the focus is the top. And so I know Cooper already kind of worked it out ahead of time. I wasn't ready to hear it yet, but we now need to go focus on the square root of 369. And what'd you say that comes out to there, Super Cooper? Okay, so we break it down into the square root of 9 times the square root of 41. You know, you've been down this road. You got to hunt for numbers that multiply where one of them is on the red list, blah, blah, blah. And this is the best you'll do, and the square root of 9 is 3. So the top does, in fact, become 3 roots of 41. And then the bottom is 2. It's like you take a 2, square it to make 4, and then unsquare it to put you back to 2 every time. Yeah. 13 squared is 160. 160. That's okay. It's good that you do it in your head. But 369 is one that we probably don't have memorized. So good so far? All right. And then the last thing we're going to do is add the 15 halves across. And this is where now you can, like, there was a step I did in the first example that I really don't think I need to write this time. You know what's coming down the pike is there's going to be the 2 fractions over there that you know you can add together, because the left side's always going to have a 2 on the bottom. The right side's always going to have a 2 on the bottom. So just cut to the chase and put them together. What do we get? X equals what? Good. So far, so good. You okay? Right. Let's do another one. That. So, you know, the autopilot kind of kicks in. We leave x squared and the 11x where they are. We clear a space, boot 26, and make him positive like this. And so it begins. What's half of positive 11? 11 halves. And then we square that bad boy. And what do we get? 100 and what? Over what? Over what? I'm sorry, what I could... Over 4. Thank you, Corbin. So we have 121. I could hear you the whole time I was just 121 over 4. Forget square the top base, square the bottom. You square it, and then later you unsquare it. I get it. It's a little weird. Yeah. Okay. So now we have to do that F word. Let's factor the left side. And again, you don't have to know anything about factoring. I guess you figured that out by now. What goes after the X? Plus. So you're sitting in this room and you still don't know how to do that. Let me say again, this number could go there. Got it? That's why it's good to have it laying around on your paper. Some people do it, some people don't. The right side, let's do some math here. What do I do to this 26 again? Multiply it by 4, and 4 times 26 is 80 plus 24, right? 4 times 20 is 80, 4 times 6 is 24, 80 plus 24 is 104. So I'm going to replace 26 with 104 fourths. And now I'm going to add those two fractions together because that's what I do. That's why I did that whole make it a 4 thing. So now what do I get? Good. And, you know, I'd like to think you recognize 225 and you go, hey, I know you. You're on my red list, right? So this is going to be a pathway problem because everything's going to kind of magically root itself away. It's going to be nice. So can I scroll this far? Everybody good? All right, let's do this. Square root the left side, you get x plus 11 over 2 equals, immediately put positive, negative. Don't even think about it. And then check it out. What's the square root of 225 again? And what's the square root of 4? And just like that, that's your indication that, hey, this is a pathway problem. So, but the math should be, by the time you're in like 10th, 11th, 9th, 12th grade, I mean, this should be simple, light work. So here it goes. Move the 11 halves, and let's look at it as what it is. It's negative 11 halves plus or minus 15 halves. Now, you can do this one of two ways, and I don't care. I'm going to let you choose. I'm going to be bossy. Method number 1 is to put the fractions together. If you find that easy, honestly, at the end of the day, it's the same thing. But like some people will do what I'm writing in green. Some people will take the negative 11 and the plus or minus 15 and put it all on top of a 2, and then they'll work out their pathways like that. So like for this person, the green person, what's negative 11 plus 15? What is 4 over 2? So for this person, one of the answers is x equals 2, right? What's the other pathway? What's negative 11 minus 15? Negative 26, right? Divided by 2 is negative 13. So you can like conjoin the fractions and then take the paths, or you can just do the pathways as they sit. Like, and it's not hard because the fractions have the same. Look at these denominators; they're both 2's. So we can just pathway this little sucker right now. Take the top road. What's negative 11 plus 15? 4 over 2, which is 2. Whoa, right? What's negative 11 minus 15? Negative 26. But you get the idea. So listen, there's no need to write it like what I just crossed out. But if that helps you to see it, feel free, of course, to do it. At the end of the day, you got 2 little fractions with the same bottoms. Yeah, you just add them together. That's easy peasy, right? You guys feel like you kind of have an idea what's going on? Say again? No, Delta does a terrible job with this. So this one was a worksheet that I conjured up. And do you guys want a paper copy or do you just want to pull it up on Canvas? What you like paper? All right, let me print it out and then we'll do a couple together. I'm gonna not stop the recording. I'm just gonna pause it for a few minutes while I print. All right, let's do 13 squared is 169. I do recall having thought to myself, if you don't mind, if you'd indulge me, that we should do problem 4. I know that seems weird because you're like, but I'm on number 1. 4 has something that didn't come up in the notes. So I think I'm recording. Yeah, so this will be included as part of the recording. Just kind of count it as notes, but also kind of killing 2 birds here. We're getting one problem closer to done, but also kind of learning something here. So can you think of something that didn't come up in the notes that, yeah, can you think of something that didn't come up in the notes that probably we need to talk about? Yeah, negative roots, right? And so the negative roots are gonna pop up. Thanks, Kinsley, I forgot about that. The negative roots are gonna pop up here in question number 4. So let's get to number 4. So first off, let's do some prep work. And you can see problems have varying prep works that need to be done. Like, I could throw whatever I want at this point. You should just know to put the squared and the regular x on the left and put the number on. So you do what you got to do. In problem 4, I'm going to leave the v squared and the minus 13v where they are. And I'm going to go ahead and move the 53. And what is 7 minus 53? Nope. If you have $7 in your bank account and you swipe your debit card for 53, you owe the bank how much? 46. Good. Okay. So we're all set, ready to go. And the algorithm begins. What is half of negative 13? Negative 13 halves. And again, I'm going to write that down so that I have that sitting over there like a beacon to remind me how to help me with my factoring step. Square this with me if you'd be so kind. And Bryce was asking about this exact thing a moment ago. It's 169 over 4. Excuse me. So we're going to add that to both sides. We're going to add 169 over 4. And then to the other side, same thing. Right, no big deal. Let's go ahead and take care of our left side because, we're air quotes factoring without really factoring. So I'm going to pop my V in there, and what's going to go next to the V? Negative 13 over 2, right? So I think I actually am writing minus 13 over 2, but same. So all good. So, all right, so factoring, check, done, great. On the right side, I've got to manipulate that whole number. It's actually an integer. What do we do to it? Always by 4. Yeah. And so can anyone do negative 46 times 4? Negative 184. Yeah. Should be negative 184. So I'm going to erase the negative 46 and put negative 184 over 4. So you see now that it's basic math that since the negative number is bigger than the positive number, then when I add these, I'm going to get a negative. So what is negative 184 plus 169? Nice. So my answer to this addition problem up here is negative 15 fourths. And so the moment this happens, and it happened more than once, is you realize, okay, I've got imaginary numbers. I can handle this. So I'm going to proceed as normal, just with the awareness that there's going to be an I, right? That's all that we got to ever worry about. So let's factor let's square root the left side. What do we get? Yeah, wipe sweat from brow. Equals positive, negative. Do not incur the $200 fine that comes with forgetting the positive, negative sign. Right? For some of us, that can be an entire week's paycheck, depending on how much you work. So you don't want that fine. Positive, negative. Now I'm going to head over here off to the side, and we're going to talk about how to deal with this. So we have the square root of negative 15 fourths. So there are 3 parts to this explanation. Part number 1 is, let's talk about the negative. What do we know the negative is going to produce? The I. I is coming in somewhere. What is the top, the root 15, going to produce? Just root 15, right? He's trash. He can't break down, so he's just going to be a root 15. And what's the 4 on the bottom going to produce? A 2, right? So we're going to put all the parts and pieces in their proper places. Parts and pieces, proper places. Yeah. So it's going to say I root 15 over 2. And alternatively, you might also see someone, honestly, I'm not going to split hairs about this, but if you ran into, say, like a college professor, don't get confused if they wrote it like this, like as long as the i's not on top. Because remember, we never put an I right after a root because then people get confused and wonder if it's inside. But if I purposely show it as like a off to the side multiplier, then this won't be bad. But as a general rule of thumb, I'm just telling you that a general rule of thumb, you should put the I right in front of a radical like that. Good, good. And this is certainly not a pathway, right? Because I mean, we got i's, roots. This is as unpathway as a problem can be. So really, we're one step from home. So we're just going to say v equals. Can we do it all at once? What's our answer? Good job, buddy. 13 plus or minus I root 15 all over 2. Well done. So should we do? You want to do another one? Are you guys? Number 2 is a what? Yeah, number 2 will definitely have an I. Yeah. You can always tell pretty well right away when it's going to be an I if, like, when you move your constant to the right side and then you get a decent sized number and then you know the fraction you're going to add across isn't going to be enough to cover it. That's how you can tell. But you don't really have to care at the beginning. Are there any others that catch your eye? Do you want me just to get out of the way and let you work? I'll leave the recording on, or we can do problems together. What would you prefer? Want to do another one together? Yeah. Number 1. That was random. All right, let's do number 8. I'm down. I love math. I'll do math with you. Let's do number 8. So I'm going to leave the n squared right there. What else am I going to change? Yeah, we're going to bring that negative 15n across as a plus 15n. And then, of course, I'm going to move that 12 over. And there it is. Foundation set. And the algorithm, the repeated process begins. What is half of 15? What is 15 halves squared? Dope. So let's add 225 over 4 to both sides. Let's factor. What does the left side become? What do we do with this number 12? 48 over 4. And then add those together, and what do you get? I believe that is correct. Now, I'm not too sure about this number 273. I know it can't be divided by 4 because it ends in a 3. I know it can't be divided by 9. I've told you this trick at least a couple times in our years together, but every time I say it, like, it sinks in for someone new and someone goes, oh, so here it is. There's a test for 9. If you ever look at a number and want to know, gosh, I wonder if I can divide you by 9, add his numbers together. It's called the digit sum test. What's 2 plus 7? What's 9 plus 3? You see how 12 cannot be divided by 9? Then the number cannot be divided by 9. That works for 3 and it works for 9. It doesn't work for other things. Like 4 has a different test, 5, they all have. You can divide by 3, correct. But that does us no good, right? Because 3 is not a square. So that's why 9 is a great question. But yeah, that test is identical for 3 and 9. So it's more useful for 9. Can this be divided by, let's take a look at this. If you divide it by 3, because we know it can, because the digit sum test told us that the digit sum was 12. 12 divided by 3 works. So this has to work by definition. What does that equal? 91. And then is 91 a prime number? I don't think it is. So here's what I'm going to tell you. 273 is a big load of garbage. 273 is one of those numbers that's like, I've got a bunch of factors. Like I've got 7, 13, 91, 3. But guess what? They're all garbage. We agree? So for that reason, we're just going to leave root 273 as root 273. He's got no component pieces that mean anything to us. So that will actually be good for us because I guess that's less work. So square root the left side, we get n plus 15/2 equals positive, negative. And what will become of the square root of 273? He'll stay as the square root of 273 over 2. No need for i's here because our radical did not go negative. Yeah, so just, did you say migrate? I like that. Let's migrate the 15 halves to the other side, giving us n equals what? Negative 15 all over 2. Bam. Just like that. Did I miss anything with 273? I believe that would be correct if I said his only factors are 3 and 91, or 7 times, what is that? Yeah, no, he has no. So, yeah. You guys feel like you got this? All right. Cool. We will work on this. I already said this. We'll work on this some more on Monday. Okay, so get what you can, get done what you can in the next 8 minutes or 9 minutes, whatever that is.